Okay everyone, so now we have to talk about the questions on the application of integrals, which is area under curves. So the first question coming up says that there are parabolas y square equals 4x and x square equals 4y. So both are standard parabolas. Divide the square region bounded by the lines x equals 4 and y equals 4 and the coordinate axis. If S1, S2, S3 are respectively the areas of these parts numbered from top to bottom, then what among these is the correct option? So first of all, understand that we have two parabolas. One is y square equals 4x. Other is x square equals 4y. Cool? So this is your parabola y square equals 4x and this is x square equals 4y. What is it is, if you wish to find the points of intersection of these two parabolas, then of course they will be coming up as this point and this point. So technically let's find the points of intersection of both these parabolas. That means from here I can say x is y square upon 4. So x square will be y to the power 4 upon 16. That I will be plugging in over here. Okay, because I want to solve both these equations simultaneously to get the value of x comma y points which are lying on this parabola as well as this parabola, because they will give me the points of intersection. So from here I can say x is y square by 4. So x square is y to the power 4 by 16. Here when you plug in x square as y to the power 4 by 16, equate it with 4y. What do you get? You get y cube by 16 is 4. That is y cube is 64. 16 into 4 is 64. So y actually comes out to be 4 and not minus 4, because you can clearly see both the points of intersection of these two parabolas are lying in the first quadrant. Basically one is origin, another one is lying in the first quadrant. So obviously the x and y, both coordinates of this point are positive, they can't be negative. So here I am not taking y as minus 4, I am deliberately fixing it to be 4, because I know that this 4 is the y coordinate of this point and that has to be positive. Okay, when y is 4, when you have got y as 4, you get x square equals 16. Again, x can be plus or minus 4, but I am fixing it to be 4 for the same reason, because the point of intersection is lying in the first quadrant, so both x and y coordinates have to be positive. So I have got the coordinates of this point as 4, 4, and obviously this point is 0, 0. If I draw the line x equals 4 and y equals 4, what would they be? So this is actually my line y equals 4, and if I draw the line x equals 4, this is my line x equals 4. You can clearly see that these two parabolas are dividing this square which is created by y-axis, x-axis, the line y equals 4 and the line x equals 4. This is 4, 0 point, and this point is 0, 4. So these four lines, the y-axis, x-axis, x equals 4 and y equals 4. This region made by both the parabolas is dividing this square into three parts. From top to bottom I have to name it as S1, S2 and S3. Okay. Now the options are that area of S1 is this much square units, of S2 is this much, of S3 is this much, and when I take the ratio of the areas of S1, S2, S3, it comes out to be 1:1:1. Before I move ahead to finding the explicit area of S1 or S2 or S3, it's important for me to first calculate this much area. This much area, which is actually S2 plus S3. So if I focus upon evaluating S2 plus S3, what do you think will this be? The curve involved is this one. Below it I wish to compute the area, and I have what? 0 to 4 as the value of x involved. So this is which curve? Y square equals 4x, so y is root over 4x, of course positive square root of 4x, because all of this curve is lying in the first quadrant. So I have integration from 0 to 4, these are limits of x, y is equals to root over 4x, positive root over 4x. This is your S2 plus S3 area. What would this be? Positive square root of 4 is 2, it will come out of the integration sign. And this is root x dx, which is nothing but x to the power 1 by 2 dx. X to the power n, integration is x to the power n plus 1 upon n plus 1. So this is 2 multiplied by x to the power 1 by 2 plus 1, which is 3 by 2 upon 3 by 2. Okay, from 0 to 4. So this gives you 4 by 3 into 4 to the power 3 by 2, which gives you 4 by 3 into 2 to the power 2 into 3 by 2. Because 4 can be written as 2 square, this 2 cancels out, you get 2 cube, which is 8. So you get 4 into 8 by 3, which is 32 by 3 square units. This is my S2 plus S3. My options are regarding one single area of S1, S2 and S3. So if I wish to compute the S3 portion, let me shade it. Corresponding to this curve, I get my S3 as everything below it. So this is my S3. Okay, so from 0 to 4, below this curve, y is x square by 4. So let's evaluate S3. Integral 0 to 4. These are limits of x. Y is, because this curve is involved, below this I wish to compute the area. So y is x square by 4 dx. So obviously 1 by 4 goes out, you're left with integral from 0 to 4 x square dx. This is 1 by 4. Integral of x square dx is x cube by 3 from 0 to 4. Okay, so this gives you 1 by 4 into 1 by 3 into 64. Isn't it? 1 by 4 into 1 by 3 as it is, 4 cube is 64. So this gives you 16 by 3 square units. So you are getting that S3 is actually 16 by 3 square units. But S2 plus S3 is 32 by 3 square units. If from S2 plus S3 I will remove S3, I will get my S2. So what is my S2? S2 is from S2 plus S3, you remove S3. S2 plus S3 is 32 by 3 square units. S3 is 16 by 3 square units. So S2 is 32 by 3 minus 16 by 3 square units, which is obviously again 16 by 3 square units. So what are you getting? You are getting that S3 is 16 by 3, S2 is 16 by 3. What about S1? Because this entire square is getting divided by S1, S2, S3, that means S1 plus S2 plus S3 is equal to the area of the square, right? What am I saying? I am saying area of the square is S1 plus S2 plus S3. What is the area of the square? The side length is 4. So area of the square is side square, which is 4 square, which is 16. So 16 is S1 plus S2 plus S3. But S2 plus S3 is 32 by 3 square units. So from 16, when I remove S2 plus S3, I get S1. That means from 16 I remove 32 by 3, I get my S1. Right? This is 48 minus 32 by 3, which gives you 16 by 3 square units as S1's area. So you are even getting that S1 is 16 by 3. Is it clear? That's how you have tackled this question. So if I talk about the options, yes, S1 is 16 by 3 square units, S2 is 16 by 3 square units, S3 is not 15 by 3, it is 16 by 3 square units. And if I talk about S1 is to S2 is to S3, it is 16 by 3 is to 16 by 3 is to 16 by 3, which is 1 is to 1 is to 1. Is it clear? Moving to the next question. Now over here in column 1, there are some figures, functions, graphs given, and in the right hand side column, that is column 2, you have the areas given. We have to match the graphs with their corresponding areas. Beginning with the first figure in column 1, which is A. It says y is x squared plus 2 and y is equal to minus x and x is 0 and x is 1. Let's draw. If I talk about y equals minus x, I know it is this line, right? What about y equals x squared plus 2? If you focus upon this curve, when you put x as 0, you get y as 2. So 0, 2, so this point is 0, 2, is certainly lying on the graph of y equals x squared plus 2. And of course, it is an upward opening parabola. If I talk about y equals x square, I compare it with it. So you will be getting this as the figure corresponding to y equals x square plus 2. Is it clear? Okay. Next, if I talk about y equals minus x, it is this line. This is y equals minus x. After that, you have x equals 0, which is the y-axis, this is x equals 0, and you have x equals 1. So this is x equals 1. So this point is 1, 0. Obviously, this point is 0, 0. The region bounded by these 4 graphs. One is this is y equals x squared plus 2. Other is y equals minus x, other is x equals 0, other is x equals 1. So of course, the figure which comes out to be is this figure. How do you evaluate the area of this figure? Let me name this figure as 1. Okay? Or you can do one more thing. This is A. Name this point as B. Name this point as C and name this point as D. So, you know, area of 1, or I can say area of the figure ABCD will be what? You can clearly see what? This minus this. Everything below the parabola minus below the line is going to give you this much when you integrate from 0 to 1. That are the limits over x. So 0 to 1, your y is x squared plus 2 minus, I am interested in below the line, so that is y equals minus x. So minus of minus x gives you plus x. Okay. So y equals x squared plus 2 minus y equals minus x. That means x squared plus 2 minus minus x means x squared plus 2 plus x. There is no symmetry. It's not that half of it I can find out and then do the twice of it to get the complete area. There is no symmetry. So we have to in one go find the area of this complete shaded region. What would this be? Now this is very, very simple. X squared plus x plus 2. You can integrate x squared. It will give you x cubed by 3. Integration of 2 is 2x. Integration of x is x squared by 2 from 0 to 1. What do you get? 1 by 3 plus 2 plus 1 by 2 minus 0. So you get 6 here. So you get 2 plus 6 into 2 is 12 plus 3, which gives you 17 by 6 square units. So the very first figure's area has come out to be 17 by 6 square units. So A gets matched to R. Let's move to the next one, which is my B option. Let's see what is the area corresponding to the figure given in column 1's B part. It is y equals x square, which is my standard parabola I know. Another is y equals twice of 1 plus 2 upon 1 plus x square. So your B is y equals x square and y equals 2 upon 1 plus x square. Now see, if I focus upon the drawing, okay, y equals x square is super simple. It is like this, okay, this is y equals x square. If I talk about 2 upon 1 plus x square, just see, let us just talk a bit about 2 upon 1 plus x square. First fact is, when you put x is 0, you get y equals 2 upon 1, which is 2, first fact. So 0, 2 is definitely a point lying on this curve. So 0, 2, say it is somewhere here. This is 0, 2. That is certainly lying on the curve 2 upon 1 plus x square. Second fact about this is, as x approaches infinity, 2 upon 1 plus x square approaches where? If x approaches infinity, 1 plus x square approaches infinity, so 2 upon 1 plus x square approaches 0. As well as when x approaches minus infinity, then x square approaches plus infinity. If x approaches minus infinity, x square approaches plus infinity, 1 plus x square also approaches plus infinity, 2 upon 1 plus x square approaches 0. So whether x approaches infinity or minus infinity, 2 upon 1 plus x square always is approaching to 0. It is never becoming 0. That means this graph will never ever touch or intersect the x-axis. Third fact is that you all know x square is greater than or equal to 0 for all x, because x square is always a non-negative function. So 1 plus x square is greater than or equal to 1, and therefore 1 upon 1 plus x square is less than or equal to 1 for all x. So 2 upon 1 plus x square is less than or equal to 2 for all x. That means you plug in any value of x in the place of this expression, 2 upon 1 plus x square will never exceed 2. At the max it will be 2 comma, it will be attaining the value 2, but never ever will it exceed 2. Keeping these 3 points in mind, the figure which you obtain corresponding to 2 upon 1 plus x square is this bell-shaped figure, which proves that 0, 2 is lying on the graph of 2 upon 1 plus x square. As x is approaching to minus infinity, 2 upon 1 plus x square approaches 0. As x is approaching to infinity, 2 upon 1 plus x square is approaching to 0, and nothing is exceeding 2. Okay, the entire graph is just lying between 0 and 2, nothing is exceeding 2. I have to find this area. For that, I will first of all have to compute this and this, so that I can get this point and I can also get this point. But before I do that, realize that this is a symmetric figure with respect to y-axis. So whatever you can see on this side, exact copy of it is on this side. So I am naming this region as 1 and this region as 2. You should realize that area of 1 is equal to area of 2. So if I am taking this as my complete shaded region, you should realize that the area of shaded region is 1 plus 2. Your shaded region can be written as 1 plus 2, but because area of 1 is same as area of 2, so area of shaded region is area of 1 plus area of 1, which is twice of area of 1. Just if I find area of this first shaded part and do the twice of it, I will get the area of the complete shaded region. After realizing what the graph is and finally coming to know the shaded region whose area you need to compute, my interest is in calculating the points of intersection. So see, here you have y equals x square, here it is y equals 2 upon 1 plus x square. I have to solve both these simultaneously. In place of x square you put y, you get y equals 2 upon 1 plus y. Okay. This gives you what? If this is y equals 2 upon 1 plus y, cross multiply, you get y plus y square equals 2, that is y square plus y minus 2 is 0. Quadratic formula, 1 square minus 8 upon 2. So this becomes minus 1 plus minus 3 upon 2, because this is 9, square root 9 is 3. Minus 1 plus 3 upon 2 gives you 1, and minus 1 minus 3 upon 2 gives you minus 2. Okay. So y is 1 and minus 2. Corresponding to 1, you get x as what? Corresponding to 1, you get x as what? Now please try to understand, can I take y as minus 2 or not? Well, you can clearly see both the points of intersections are lying in the first and second quadrant, that means in the upper half plane. In the upper half plane, corresponding to any point, the y coordinate is always positive. Whatever this point is, its y coordinate cannot be negative. Whatever this point is, its y coordinate cannot be negative. So y coordinate is not allowed to be minus 2, it will have to be 1. So this point will have y coordinate as 1. This point will also have y coordinate as 1. Okay. Now when y coordinate is 1, x square is what? 1. So x is plus minus 1. Right? So this is actually 1 and this is minus 1. You can see it is completely symmetric. So this point is 1 comma 1 and this point is minus 1 comma 1. From 0 to 1, I will do what? Integrate this minus this. That means everything below the bell-shaped curve and minus everything below this parabola, and integrate it from 0 to 1 to get the area of the first part. Let's do this. So you get integration from 0 to 1. I am calculating the area of the first part, everything below the bell-shaped curve minus below the parabola, which is y equals x square dx. And I have to do the twice of this complete expression to get my complete area. Fine. So this will be equal to twice of integration, 2 comes out, you get 1 upon 1 plus x square dx from 0 to 1 minus integration 0 to 1 x square dx. Okay. This gives you tan inverse x from 0 to 1, because integration of 1 upon 1 plus x square is tan inverse x, minus x cube by 3 from 0 to 1. Okay. This is twice of, what is tan inverse of 1? It is pi by 4, and tan inverse 0 is 0. So twice of pi by 4 minus 1 by 3. This gives you this. 2 gets multiplied, you get just a pi minus 2 by 3. 2 gets multiplied by pi by 2, 2 gets cancelled, you have pi minus 2 by 3 square units. So pi minus 2 by 3 square units is the area of B. Talking about C, let's see what option C has to say. I hope this is very clear to you. Talking about C, it is y equals sin x and y equals cos x. It is just asking us to find the area corresponding to any one region. It means that it is asking us to consider just one cycle. So if I talk about sine, this is one cycle of sine, this is 0, pi, 2 pi. Talking about cos, this is one cycle of cos. This is 0, this is pi by 2, and this is 3 pi by 2. If I talk about this point, and this point. See, this is your sine graph and this is your cos graph. I have to find which area? I have to find this area. Between two what lines is this area bounded? It is bounded between this line and this line. This is x equals something and this is x equals something. What are the points of intersection of sin x and cos x? Corresponding to what values of x is sin x equal to cos x in the interval 0 to 2 pi? In the interval 0 to 2 pi, what are those values of x at which sin x is equal to cos x? You know that sin pi by 4 is same as cos pi by 4. So first of all, this angle is pi by 4. So this point is pi by 4 comma 0 and the equation of this line is x equals pi by 4. After this, you know that sine of pi plus pi by 4 is same as cos of pi plus pi by 4. Do you realize that? Sine of pi plus pi by 4 is same as cos of pi plus pi by 4 and therefore this point is pi plus pi by 4, which is 5 pi by 4 comma 0. So this line is x equals 5 pi by 4. So how do you compute this area? Basically what you do, this is sin x, so sin x minus cos x. Everything below sin x minus everything below cos x will give you this area when you integrate it from pi by 4 to 5 pi by 4. So the area of the shaded region is integration from pi by 4 to 5 pi by 4, everything below sin x minus everything below cos x. Okay. This is nothing but pi by 4 to 5 pi by 4 sin x dx minus pi by 4 to 5 pi by 4 cos x dx. Integration of sin x is minus cos x from pi by 4 to 5 pi by 4 and integration of cos x is sin x from pi by 4 to 5 pi by 4. This gives you what? Minus comes out common. Cos of 5 pi by 4 minus cos pi by 4 minus sine of 5 pi by 4 minus sine pi by 4. So what is cos 5 pi by 4? It is cos of pi plus pi by 4. What is cos of pi plus theta? It is minus cos theta, which is minus 1 by root 2. So this value is minus of minus 1 by root 2. Cos pi by 4 as it is 1 by root 2 minus. What is sine 5 pi by 4? Well, you know that cos 5 pi by 4 and sine pi by 5 pi by 4 is same, right? Because if you write sine of pi plus pi by 4, it will come out to be minus sine pi by 4, which is minus 1 by root 2 again. Okay, so this is again minus 1 by root 2 minus again sine 5 pi by 4. Sine pi by 4 is 1 by root 2. This is minus 1 by root 2, this is 1 by root 2, minus 1 by root 2, this is 1 by root 2. Eventually you get what? 1 by root 2 plus 1 by root 2 plus 1 by root 2 plus 1 by root 2. So 4 times of 1 by root 2. What does this become? 2 into root 2 into root 2 into 1 by root 2, which gives you 2 root 2 square units. Is it clear? And therefore your C gets matched to B. Is it clear? Let's just write it down. A has been matched to R, B to Q, C to P. A gets matched to R, B to Q and C to P. So I hope you've got the understanding of how I have solved this question and the previous one as well. Please go through them, revise them nicely. I'll see you in the next session. Thank you.